Hey guys, I'm Jeremy Hillier, Product Manager for Velo.io. And today, I'm going to tell you how big data streaming doesn't have to be complex, even if you're doing the really complex stuff. It's a bit about myself. I started my career in software engineering before moving to product management, so I enjoy the technical stuff. And I got interested in big data through my work with utilities about 10 years ago. So this is about the time that they were switching all the meters for smart meters. The main thing being, rather than having guys literally walking around the country taking meter reads every 3 months, suddenly we've got these devices which are sending data every half an hour. So for us, this was an increase from 80 million reads a year to 350 billion reads a year, which is huge. There was a lot of technical challenges dealing with the explosion in data, but what really kind of kept us up at night was, what do we do with the data? There's huge amounts, and there's clearly stuff that can be done. So for us, we embarked on this pretty major multi-year project. We were doing all sorts of batch analytics on this data. So we're looking at things like, is a dip in consumption due to someone going on holiday, or is it due to fraud? Or how do we model the demand in a region or a cohort? Or how can we nudge consumption to fit supply patterns? We spent several years doing this, and we kind of got there, but it took a lot of time and a lot of money. Since then, I've been working more on the investment bank side, and suddenly we're talking about much bigger numbers, and the timings are even more critical. But fundamentally, it's the same problems. We've got complex estates, we've got messy data, we've got risky projects, and above all, we've got questionable return on investment. So, I'm going to talk really quickly, 10-15 minutes or so, to answer a few key questions about what we're doing now. And I'll leave a little bit of time at the end for Q&A, or if you want technical information, just come and see us at the stand. So let's start by looking at my first question, which is, what are the problems with traditional approach? Now I'm going to break this down into a few sections, the first of which is that timeliness really matters. So what do I mean by that? Well, what I mean by that is that increasingly, and across the board, yesterday's analytics just don't cut it anymore. If you think back to my use cases from before, things like fraud detection, churn detection, when we were dealing with it then, it was kind of all right. You'd set the batch going, you'd go home, and in the morning you'd have your answer. It was kind of okay, you can act upon it the next day or whatever. Not anymore. I mean, even for utilities, the real challenges these days are way more time sensitive. So demand-side management, which is something we've been working on. And this is basically balancing your demand with your supply from renewables, which is variable. And here you're talking literally minutes to make sure that supply and demand are in sync. Finance, it's even worse. So suddenly we're talking about going from making minute-by-minute adjustments to second-by-second, or even faster. So foreign exchange, for example. As of May last year, there's $5.1 trillion traded every day, which is more than $61 million every second. So you can imagine, it's getting this stuff done on time is critically important. We think of it a little bit like an ambulance. If you need urgent medical attention, you need it right now. You don't have time to wait till tonight or tomorrow morning. You need it immediately. And it's exactly the same with your analytics. There's always going to be room for less time-critical analysis, reports, metrics, things that you don't use so frequently. But when you're in the trenches, when you've got someone screaming down the phone, when you need to make a decision quickly, you've got to have real time. So that's timeliness, and I've told you why that matters. But the next real kind of challenge I always get is running a dual system is incredibly complex. And there is some truth to that. So this is Cisco's reference implementation for Lambda architecture, which is real-time and historical. Oh, sorry about the resolution, but I mean, you get the general idea. You've got Kafka, you've probably got Zookeeper, you've got Spark, maybe more Zookeeper. You've got Hadoop, Cassandra, maybe various kind of repositories, and then on top of that, you're going to attach some sort of real-time component. And if you're really lucky, you've got a team of people who know how to use all that. So, I mean, you're probably all aware there's complexities in dealing with it. It consists of ensuring that a variety of technologies are correctly configured, fully configured, and working together properly. And what people forget, even after the implementation, of course, is not only does it take an entire team of engineers to get this thing off the ground, but you also need a whole team of support functions to implement and maintain it. Let me give you an example. A tier 1 investment bank we were working with last year, they had a project to add real-time to their Hadoop cluster. Kind of a slight variation, but not far off what you're seeing here. They spent 4 people, took almost a year, and at the end, they still had a lot to do. I mean, integration, it really isn't as straightforward as you'd think, especially when you're dealing with different technologies that maybe they have different philosophies about the ways that things should be done. Getting things working well together is often more of an art than a science. My one typo is 53, half a million Swedish krona, 4 developers, 11 months. Back of the envelope, we're talking about 2 million krona minimum for doing that kind of a project. And at the end of it all, they weren't finished. And that was a near reference implementation, nothing fancy, and dedicated resources in-house. Sounds kind of crazy. But according to Gartner, 15% of businesses last year managed to get their big data project into production. 15%. We keep hearing about people like they're building all these complex things really to achieve something that's fundamentally quite simple. So why don't you flip it on its head? Why don't you get something simple to achieve the complex? I've told you about how the timeliness of analytics is important, particularly for businesses like banking and utilities. And I've talked about how a system that handles both real-time and streaming can be incredibly complex. And that brings me to my next question. Well, what's the answer? Well, the answer is Velo. Now, Velo is something we've built from the ground up to be a fully integrated streaming and historical analytics engine. So if you cast your mind back to that horribly resolution Cisco diagram from before, that's what we're talking about traditionally. Here's the same diagram for Velo. Very simple. You've got a repository for semi-structured data, so you can deal with indexing, flexible ingestion, document search. You've also got a repository for time series data, which is pretty hot at the moment. This is for dealing with very heavily structured machine data, high performance queries, that kind of stuff. Then you've got an execution engine for performing analysis wherever the data is. So it could be data streaming in for immediate analytics, or data that you've saved previously into one of those repositories. I mean, Velo handles the analytics wherever the data is, regardless of where it came from. Finally, clustered. So if you need more power, just add more nodes. Simple. So we've got analytics covered, both real-time and historical. But what about data ingestion? What we see is that the number of devices and sensors sending data is literally exploding. I mean, the smart meter example I gave before, we thought 350 billion reads a year was a really big number. That kept us up at night at the time. And frankly, these days, that's nothing. The amount of data that we're ingesting is skyrocketing. And unfortunately, that goes hand in hand with the burden to administer it. So our solution are the Velo collectors, for gathering data. So these are simple apps that communicate intelligently with Velo, controlling how and what they gather. So imagine a scenario where you've got elastic architecture. You're spinning up and down new servers, new Docker containers, whatever. You spin up a new instance, and a collector gets spun up alongside it, connects to Velo, downloads the scripts it needs, and starts sending data all seamlessly. So on the Velo side, administering this is simple as defining a policy. So this could be something like, deploy my security bundle to all collectors on devices in Sweden, or collect the log files from all the machines running Apache. So once you start thinking about your data collection in terms of policy, suddenly it doesn't matter if you're collecting data from 100 devices, thousands, or millions. It's exactly the same amount of admin. So as you can see, the unified approach we've taken with Velo means the analysis is simple, whether it's batch jobs and historical data, whether it's screamingly fast analysis on real-time streams, and equally, the unified approach means data collection is simple, regardless of the scale of your estate. And that leads me to the final question. So what? How does this create value? For those of you that have been paying attention, this should be pretty easy. You got value created through the ease of implementation. It doesn't take a year to start up insights. You should be able to get it running in under a day. And you're not running the risk of a project that's going to collapse under its own weight. So that investment bank project before I was talking about, where they spent a year putting together the various technologies to add streaming to their Hadoop cluster. Imagine if they'd had this all-in-one solution like Velo from the start. They came to us, we got the architecture sorted in less than a week, leaving them to focus on the really interesting task, which is their use case. You got value created through the flexibility of ingesting any data, structured or otherwise. So for banking, think about the analysis you can do between, say, fixed messages, infrastructure logs, and market activity. You know, is my trading causing problems on my infrastructure? Or the correlation between content of research papers and market sentiment, these kinds of things. You got value created by the combination of real-time and historical data. Think things like comparing real-time energy usage versus your historical averages for that cohort versus the prices on the spot trading market. You got value created by being able to collect data from millions of sensors without any extra admin. You can spin machines or images up and down, and Velo takes care of it all seamlessly. So we can do this because we built Velo from the ground up with a single-minded purpose and all the components working together. Sounds easy? Sadly, it's not. One of the main criticisms of Lambda or Kappa architecture is how complex it is, and honestly, there is some truth to that. I mean, we've handled a huge amount of complex stuff so that you guys don't have to. Simple. Low cost of ownership, easy to set up, easy to use. And in conclusion, I've talked about how the timeliness of analytics are important, how the world has moved on from pure Hadoop and batch analysis, and how it's the combination of streaming and batch analysis that brings the real value. I talked about the complexity of Kappa or Lambda architecture that combines the two, and how the complexity directly translates into business risk, a la the investment bank. Finally, I've talked about how Velo masks this complexity, so you can just get on with the really interesting stuff without the technology getting in the way. And that concludes my presentation.